We're going to start chapter 8 with a review of direct variation. So this is a concept from Algebra 1, and we've talked about it this year as well. This is a special type of linear function that has a y-intercept of 0. So a straight line that runs through the origin. The equation for that is y equals ax, which is the a is referencing the constant of variation that I have here circled in green. What we can say about this equation is that y varies directly with x. That's what this squiggly line right here in between the y and the x means, that y varies with x, and it's going to vary directly. Some examples of this type of equation: y equals 3x, y equals 1/2 x, and even y equals negative x over 5, because this, if we were to pull the constant of variation out, that you would end up with that negative 1/5. So you can see that x and y still vary directly with each other. They still follow this pattern right here. The new concept is inverse variation. So in inverse variation, y is not varying directly with x, it's varying inversely. So our constant of variation, we still have that idea. So we've got that here with a in the numerator, is actually divided by x instead of being multiplied by x in direct variation. You could also think about it as a being multiplied as 1 by 1 over x, and you can maybe see it a little bit clearer there. So y down here, it does not vary directly with x, it varies directly with 1 over x, but we call that inverse variation when y is varying with the reciprocal. Okay, examples: y equals 2 over x, y equals negative 5 over x, and you can see here if I pull out the constant on this one, it's going to be, if I pull that out, that fractional part out, it's 1 over x times 2. So that looks a little bit more like what I showed over here. And then same thing here. I can pull out that 1 over x, and that's being multiplied by negative 5. Okay. This graph, when we graph it, is going to look similar to this one I have drawn right here. Would be considered like the parent function of this function. All right, so what we need to do now from here is go over and look at numbers 1 through 4 and see if we can figure out what kind of variation we have, or we may not have any variation. That is also a possibility that you probably should remember from when we were talking about direct variation equations prior to this. 1 and 2 are already solved for y. So I'm going to go ahead and solve 3 and 4 for y as well, because we can't really state anything about any of these functions until we have y isolated. So that would be y equals 3 over x, and then over here I'm going to end up with 4 divided by x. All right, so then let's go back to number 1 and talk about that. You can see here we have a linear equation, but we have a y-intercept of 3. So this is actually following y equals mx plus b form, which is the only difference there between that and y equals ax is that in y equals ax we have a y-intercept of 0. The a is still serving as the slope, but we just changed the variables there a little bit. All right, so this, because it's not running through the origin, does not show direct variation, and it definitely doesn't show inverse variation. We don't have anything being divided by 2. This 2 is being multiplied by x, not divided by x. So this one is neither going to be direct variation or inverse. Over here, y equals x over 3. You can pull the 1/3 out and see a little more clearly that y and x are varying directly. So x is being divided by that 3, not the other way around. Okay, and so our constant of variation is 1/3. That's our a. This shows direct variation. And then here in number 3, this is our first one that shows inverse variation. This follows the formula over here, y equals 3, the constant of variation, over x. So this one is inverse. And then the last one looks the same as number 3. It's just that we've got a 4 as our constant of variation instead of 3, but it is being divided by our x, and so this one is also showing inverse variation. Now we can take all of these concepts and move down to number 5, where they ask us to write an equation that relates x and y, and they've told us x and y vary inversely. So if they're going to vary inversely, that means that our form that this equation is going to take is the inverse form, y equals a over x. I have my x, I have my y, so I'm going to plug those two in and solve for my constant of variation, which is a. I'm going to take that constant of variation, plug it back up into here to get my equation that I can use to solve for any x and y now. So we're going to leave the x and y open like we always have when we do these types of problems. And now I can do the last part of the question, which is to evaluate x at 1/2. So find y when x is 0.5. And that will give us a y of 48. And do the same thing on number 6. They gave us our y and our x. Oh, x is 2. And I don't even need to do any algebra here. I mean, this is a proportion. If our denominators are both 2, then our numerators are both going to be 5 as well. So here I can just look at that proportion and see that my a is 5. Take that and put it back into our form to give me y equals 5 over x. So here is my inverse variation equation. And now I'm going to find y using this equation, and I'll get a y of 10. All right, and number 7. We can use proportions here as well, or I could just cross multiply across that equation, across that equal sign. It'll give me an a of 4. So my inverse variation equation for this set of values looks like that. Constant of variation of 4. And I'll evaluate when x is 0.5, and that will give me a y of 8. Now we can also, moving down to the bottom of the worksheet, we can find whether we have direct variation, inverse variation, or neither from a table of values. And so the method for this is to go through the table of values, and to check for inverse variation, you would take your x's and y's and multiply them together. So on number 11, if I'm going to check for inverse variation, I'm going to go through my table of values, and I'm just starting with that first point and saying 1 times 1 equals 1, 2 times 4 equals 8, 3 times 9 equals 27. I can stop here because what I'm looking for right here is a constant. If this shows inverse variation, then when I multiply my x and y together through the table, I should get the same constant number. Because I don't, then I know that this does not show inverse variation. Right? I can do the opposite of that, y divided by x, and your y's need to be, it needs to be change in y over change in x. If I go through my table of values and do that, I get, again, I am not getting a constant, right? I'm not getting the same number. So since I multiplied the two together and divided the two together and neither one of them gave me a constant, I know that this function here with this particular table of values is not going to have either type of variation. I can do the same thing with number 12. X times y, I mean, we can see that pretty clearly. 5 times 24. That'll give me 120. 8 times 15. 120, and 15 times 8, 120. So here I'm getting 120 repeatedly, that's my constant. So that means that since I multiplied them together to achieve that constant, that means that this particular set of values is going to give me inverse variation. If I move over to 13, I'll check x times y first. 1 times 7.5, 7.5, but look, I can see right away 4 times 30 gives me 120. So I'm not going to get the same number, so I can just move on and try y over x, change in y over change in x. That's my first set. Then I'll move over to 30 divided by 4. This also gives me 7.5. Right, and then just keep moving across that table of values. This will give me 7.5 as well. And then I can see that 75 divided by 10 here will also give me 7.5. So I'm getting the same constant throughout. And so that follows this pattern number 2 over here in your notes that shows that this is a direct variation, a set of numbers, a function that shows direct variation. On the back of the worksheet, they introduce us to a concept called joint variation. And joint variation is it's not really a new type of variation. It just has more to do with the fact that it involves more than just two variables. Okay, so more than two variables are involved, and they will vary directly with each other. So more than two variables which vary directly with each other. Okay, so in this set of directions, they give us a z, an x, and a y, and they tell us that these variables vary jointly, which means they all vary directly with each other. They want us to use the given values to write an equation relating x, y, and z, and then find z when we have x of 4 and y of 7. So since they all vary jointly, the formula for this is z equals a, that's our constant of variation is a, times xy. So all we have to do is take these three variables that they gave us here and use them to solve for our a. Right, so we'll end up with an a in this particular equation of 2. And then I'm going to take that and put it back into the formula, leaving z, x, and y, all three of them now, need to stay open. We're just going to fill in a. So there's the equation. And now we're going to use the equation to evaluate z when x is 4 and y is 7. So z equals 2 times 4 times 7. So in this particular set of values, z would be 56. All right, and then in 15, we would use those three values to solve for an a of 8. So a of 8 put back into our form will give us this equation here, and then we'll evaluate at 4 and 7, and we'll get a z of 224 for that set of values. So that's hopefully pretty straightforward as long as you just stay familiar with the term jointly varying, meaning more than two variables, and keep this form in mind for this type of problem.